Number 3 from section 10.3. And the directions here in exercises 3 and 4, plot each point with the given rectangular coordinates and find two sets of corresponding polar coordinates. Well, we have lots of polar coordinates, so there's lots of ways to do the two different sets. But first of all, let's just plot the points. So these are my 4 points. Negative 1, 1, that's A. 1, negative the square root of 3, which is about 1.7, so 1 about negative 1.7. C was 0, 3. That's all right, and D was negative 1, 0, so that should have been pretty easy to plot those 4 points. And then we wanted to find two sets of corresponding polar coordinates. So remember, R equals the square root of x squared plus y squared. Remember, R from our polar conversions, I wrote these down in number 1. We know that R squared equals x squared plus y squared, so R would equal the square root of x squared plus y squared, and theta would equal the arctangent of y over x, so we're going to use that also. So x squared plus y squared to figure out our r. So if we look over here, we have 1, 1, so negative 1, 1, so negative 1 squared plus 1 squared, that's x squared plus y squared. That's just going to be the square root of 2, so there's your r. And then the tangent of theta equals y over x, so that's going to be 1 over negative 1. And then we know that theta would equal the arctangent of y over x, and that's going to be, like I said, 1 y over x, 1 over negative 1, which is just negative 1. So the tangent is negative 1 when theta is in the second quadrant. Okay. And that's one way to write it in the second quadrant. And this also puts it in the second quadrant also, because if I go negative 5 pi over 4, I'm going pi over 4 pi over 4 is 180, so that's going to also put me in the second quadrant. So these are two different ways to write it. It's the same thing. So we could write it either like the square root of 2, 3 pi over 4, or the square root of 2, negative 5 pi over 4. You're going to get exactly the same angle there, so they both work. So those are two different ways of writing it in polar form. Like I said, they're infinite. You just keep spinning it around. Okay, letter B. The point was 1 negative square root of 3, so r equals the square root of x squared plus y squared. So 1 squared plus negative square root of 3 squared, that's just going to be 1 plus 3, which is going to be 2, or plus or minus 2. It works either way with the way these polar coordinates work out. So that's going to be my r. My tangent of theta will equal y over x. So theta will equal the angle whose tangent is y over x, or negative square root of 3, and that's just going to be negative pi over 3. And another way of writing that is 2 pi over 3. Negative pi over 3 puts it in the fourth quadrant, and 2 pi over 3 puts it in the second quadrant, and that's where it's negative. So tangent's negative in the second and fourth quadrant. So now you could write it as 2 negative pi over 3, or negative 2, and then 2 times the square root of pi over 3. And you're going to get the same point. And you think about this. If you look at it, B, it's over here in the fourth quadrant. So if I take 2 and I go negative pi over 3, pi over 3 is about this angle. It's going to be over about this way. And this will be 2, because that's that distance. So it makes sense that this would be in the fourth quadrant. Now this one over here, this is a little tricky. This one's a little tricky. If I go 2 pi over 3, 2 pi over 3 will put me in the second quadrant. But instead of going in this direction, which is just right up over here, it's going to go negative. So I'm going to go back this way. So that's also going to get you there. So the angle's over here. It's along this line, but since we're going to be negative, we're not going to go in the positive direction. We're going to go negative 2, and that's going to put me down there also. So it would work out. Okay? And we did some polar coordinates in the summer assignment, so hopefully if you look over those, review those, it should all make sense. Okay, the next one was letter C. And that was the point 0, 3. So first of all, I find my r by using the square root of x squared plus y squared, the square root of 0 squared plus 3 squared, which is just the square root of 9, which is plus or minus 3 again. Now the tangent, now this is a little tricky because the tangent is, of theta is y over x, and I get Theta is the angle whose tangent is 3 over 0. Now, 3 over 0 is undefined, but that's where we have asymptotes. Remember, our tangent has asymptotes at pi over 2 and negative pi over 2, and that's where it's undefined, so that's going to be what theta is. So you have to kind of know your graphs. So again, I'm going to be over here at pi over 2, and that does look like, see, this is pi over 2, 3 pi over 2. But if I did negative pi over 2, I'd be down here. But then if I went negative 3, it'd be back up here. So we could write it both ways. Pi over 2 up 3, or negative pi over 2. Instead of going out 3, I go backwards 3, and I still get to the same point. That's how those polar coordinates work. Okay. And the last one, letter D. This is my point, negative 1, 0, so r equals the square root of x squared plus y squared, so negative 1 squared plus 0 squared is just the square root of 1, which is just plus or minus 1. And then I could write it a couple ways, we're just using positive 1, it's not that difficult. So theta equals angle whose tangent is 0. Well, a couple of angles that have a tangent of 0 would be tangent of 0 is 0, and the tangent of pi is 0. Okay, if you look at your tangent graph, you'll see that. So we could try, so we know we're going to be over here at negative 1, 0, so we should be over something like this. So we could try negative 1 and this 0 angle. So this would be the 0 angle, but if I go negative 1, if I go negative 1, it would be like this. In other words, this is the 0 angle over here. So that means that that's the terminal angle. That means that's the angle it makes with the positive x-axis. But then if I'm going to go in the negative direction, instead of going this way, I go that way, negative 1. And this would be 1 pi. Now pi would go like this in this direction, so that's pi. And then if we go 1, that's going to be out, because that's always positive. We don't think of this as a negative, because r is always going to be, this is going to be the direction it comes from the pole. This is the pole, so if r goes like this, it's positive. If r goes like that, it's negative, depending on my angle. So in this case, the angle is pi, so it'd be like this. So this would be in the positive direction. If I went in the negative direction, I would get positive 1. It's kind of strange the way that works. I would have my point over here. If I went in the positive direction, if I went in the negative direction, because if this is the angle 180 degrees, we're going out in this direction. So a positive r is going in this direction, a negative r would be going backwards. It's kind of strange the way that works out, but that's what you get. So you have to think about those a little bit and think about your polar coordinates and how this works. Okay. Again, the pole is actually the center. So if we're going in this direction, that would be positive r. If this is the angle, if we're going this direction, that would be negative r. Okay? So I hope that kind of makes sense.